Alright, let's do some Mathity-Math. So it says here, solve for x by factoring. And what we see here is we have a quadratic. Now we know it's a quadratic because it is a second degree polynomial. That means the highest exponent is a 2. So this is a quadratic. And we want to find the roots or the x's or the zeros or the solutions. What this is, that's where our quadratic crosses the x-axis. So that's what we're trying to find, these x values. So to do factoring, this is just one way that you can solve quadratics. And there are many, but they want us to practice factoring. So let's practice factoring. We need to first understand that this is in standard form. And what this means is there's an a, b, and a c. I'll go ahead and write those down. This is an a value, and your a value is actually 1. You have a b value, which is negative 13. And you have a c value, which is negative 48. So you have a, b, and c. And the key to factoring is you start with c. And what you got to do is you got to find a set of factors for c that when you add them together will give you b. Okay, so step 1, let's list out the factors of negative 48. So we have 1 and negative 48 because 1 times negative 48 is negative 48. And if you think about this, we're going to leave all of our negatives on the larger factor because when we go to b, we can see b is negative. So if b is negative, that means this larger number has to be negative because when we add them together, the sum will also be negative. So I'm going to leave the negatives over here, and that's a good trick to save some time. So we have 2 and negative 24, 3 and negative 16, 4 and negative 12, and 6 and negative 8. So now we just go through and we add these together and try to figure out which one's sum would be negative 13. So 1 plus negative 48 is negative 47. That's not it. 2 plus negative 24 is negative 22. So that's not it. 3 plus negative 16 is negative 13. And yeah, that's what we have right here, negative 13. So this is our winning set. What this lets us then do is come over here and we just write a set of binomials. So we say x plus 3, because we use this positive 3, close that up, and then we just say x minus 16 equals 0. And what we've done here is all we've done is factored this quadratic. Nothing is actually different. We just wrote it in a different way. These are actually the exact same things. And if you don't believe me, what you could do is quickly multiply these together, and you should get right back to where you started. And this is a good way you can check to see if you're on the right path. So if I quickly FOIL this, x times x is x squared. 3 times x is 3x. X times negative 16 is negative 16x. And 3 times negative 16 is negative 48, which equals 0. And if you combine these, you'd get negative 13. And you see it's the exact same thing. So we're on the right path. So coming back here, we have x plus 3 multiplied by x minus 16 equals 0. Now because these equal 0, we can use the zero product property, which tells us if these two things multiplied together equal 0, then that means either all of this is 0, or all of this is 0, or they're both going to be 0. So the zero product property, what it lets us do is set each binomial equal to 0. So because this multiplied by this equals 0, I can say, well, then I know x plus 3 is 0, and I know x minus 16 is 0. So up here, oop, you can't even see that. I'm sorry. There you go. So I have x plus 3 is 0, and x minus 16 is 0. And what I did was I just took each one of these binomials and set them equal to 0. So then just using our algebraic skills to solve, I could find here, well, then x is negative 3 and x is positive 16. And these are our two solutions. And these are what we would consider roots or zeros. But essentially, it's where your quadratic, where that parabola, crosses the x-axis. So this parabola crosses the x-axis at negative 3 and positive 16. All right, that's it. As always, if you want to be notified when I make you a new video, please subscribe. And if there's anything you need me to clarify or there's a problem you need to see, just leave a comment below and I'll try to do that for you. Thank you. Bye.